All right. So continuing on with the notes, we are on page 76 and we're talking about sample space. And sample space is one of the most important things. I cannot stress it enough. If you will make sample spaces, you're going to score higher on the test. Just the case. So and by the way, one of the key things that lets you know whether you need to do it, if you have to play something twice, I mean, I don't care who you are, you really need to consider making sample space. So the classic example are the dice questions where you're rolling two dice. So what's the probability of rolling a fair-sided dice twice and getting the sum less than 8? And by the way, when it comes to doing these, you should take before the exam, the day before the exam, you should write down this 4 times as fast as you can. And I just write down 1, 1, 1, 2, 1, 3, 1, 4. And by the way, I did that this morning. I just decided if I used a pre-printed one. So 1, 1, 1, 2, 1, 3, 1, 4. So you should just write these down as fast as you can. Do it 4 times. That way you don't have to think about it. All right, so after you've done it, and by the way, there's only likely to be one of these questions on a test. It's not like you're going to use it a ton of times. You may get to use it twice. The fact of the matter is, when you do use it, it's going to help you out. So in this case, what is the probability of rolling a fair-sided dice and getting a sum, keyword there being sum, less than 8? So when I add up the two values on the die, they need to add up to less than 8. Well, 2 and 6, 3 and 5, all of these are 8, so I need to be less than 8. So how about 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. All of those are less than 8. Well, when I look at this, I know I have 36 outcomes. I know that because 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 times 6 is 36. So that gives me my denominator. My numerator is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 out of 36. And by the way, that was not too bad of a problem once you had the sample space paid. Prior to that, it's a little more challenging. Okay, given that the sum is less than 8, now please remember, given is in the denominator, what's the probability the sum was equal to 5? Given that it was less than 8, what's the probability that it was equal to 5? Well, we already have this. We already know givens in the denominator, and we have 21 that are less than 8. But of those, how many are less than 5? Or, excuse me, less than 5 was equal to 5. So what's the probability that it was equal to 5? Well, this would be this row right here, or this set, because 1 plus 4, 2 plus 3, 3 plus 2, 4 plus 1, all of those equal, sum up to 5. And there's 1, 2, 3, 4 of those. So my answer is 4 over 21. And by the way, I guess I should write this here, 21 out of 36. And now we have 4 over 21. Given that the sum is less than 8, so we're continuing on with that same problem of less than 8. So I'm just going to go ahead and circle that off. These are the ones that are less than 8. And since that's the given, and we know that there's 21 of them because we previously counted, all right, what's the probability the sum was greater than 4? All right, so greater than 4. So in other words, we can't be these smaller ones. We have to be that group. Because this adds up to 5, this adds up to 6, this adds up to 7. All of these are greater than 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 out of 21. And the last one, given the sum is less than 8, what's the probability the sum is 3 or less. So this time we're actually including the number. And once again, less than 8. So we're looking at these numbers right here. And that's my denominator. So we know the denominator of this case is 21 because we've done this several times now. What's the probability the sum is 3 or less? Well, 2 and 1, 1 and 2, and 1 and 1. All right. So in this case, there's 1, 2, 3 values that are 3 or less out of the 21 values that were less than 8. All right, continuing on. What if the die had been weighted and the probabilities were as follows? So no longer are we working with a fair die. Our probabilities should have been, if it was a fair die, it would have been 1, 6, 1, 6, 1, 6, 1, 6, 1, 6. Or 1, 6 for getting a 1, 1, 6 for getting a 2, etc. Calculate the probability of doubles. All right. Well, once again, this little chart's going to help me out just a little bit. Maybe not a whole lot, but some. It's going to say, hey, I need a 1, 1, a 2, 2, a 3, 3, 4, 4, 5, 5, 6, 6. Those are my doubles. All right. So calculate the probability of doubles. Well, that means I need to get a 1, 1. So this is 0.1 times 0.1. Plus, I need to get a 2, 2. Probability of a 2 is 0.1. But I need 2 of them. Plus the 3, 3. 0.1 times 0.1. Better put an addition sign there. Plus, I need a 4, 4. And I would say 0.2 times 0.2. Plus, I need the 5, 5. Running out of room. Plus 0.2 times 0.2. And then I need the 6, 6. Which is going to be plus 0.3 times 0.3. All right. So this ends up being 0.01 plus 0.01 plus 0.01 plus 0.04 plus 0.04 plus 0.09. And now all that adds up to my final answer of 0.20. Calculate the probability that the sum equals 6. My little table helps out a whole lot again. All right. So I need them to equal 6. Well, where do they equal 6? 1 plus 5, 2 plus 4, 3 plus 3, 4 plus 2, 5 plus 1. All right, those are the ones that equal 6. So in this case, we're going to need a 1 comma 5 plus 2 comma 4 plus 3 comma 3 plus 4 comma 2 plus 5 comma 1. Well, the probability of a 1 was 0.1, and the 5 is 0.2. 2 is 0.1. The 4 is 0.2. The 3 is 0.1. Four is 0.2. The 2 is 0.1. And then the 5 is 0.2, and the 1 again is 0.1. When I add all of those up, I end up getting 0.09. Okay. All right. This is the next one, very, very difficult question. It has been on, or one similar to that has been on the test for years, so you can expect to see one again. A game of chance is played in which X, the number of points scored in each game, has the distribution shown at the right. So we have a distribution of X. You can get either 0 points, 1 point, or 2 points. And the probability of getting 0 points is 0.3. The probability of getting 1 point is 0.4. And the probability of getting 2 points is 0.3. What is the sampling distribution of the sum when the game is played twice? As soon as they say they're playing it twice, I know I'm in trouble. I know I'm going to have to make a sample space. So I could get a 0, 0. I could get a 0, 1, or a 0, 2. I can get a 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, and 2, 2. Let me explain that real quickly. I could have gotten 0 points on the first game and 0 points on the second game. I could have gotten 0 points on the first game and 1 on the second, or 0 on the first and 2 on the second, so on and so forth. This will be getting 1 on the first and 2 on the second. This will be getting 2 on the first and 2 on the second. So I need to go ahead and start filling in those probabilities. Well, what's the probability of getting 0 points? Well, that would be, in this case, that probability of 0 is 0.3. And the probability of getting 0 is 0.3. So 0.3 times 0.3 equals 0.09. The probability of 0 is still the 0.3. So basically, anywhere I have a 0, I can probably put in a 0.3 and I'll be fine. The probability of getting a 1 is 0.4. So I can go ahead and put a 0.4 everywhere I have a 1. This time I have 2 1s. All right. And then if I multiply, and then everywhere I have a 2, the probability is 0.3. So I can go ahead and fill that out. So then I have everything into the table, and I just need to multiply. Point 0.3 times 0.4, 0.12, 0.09, 0.12, 0.16, 0.12, 0.09, 0.12, 0.09. That does not look like an 09. All right. So what are my possible outcomes? 0 plus 0 is 0. So someone could get a 0 points total. The only way, and the probability of getting that is 0.09, because the only way to get 0 is to have on first 2. So this is 0.09. By the way, I should back up just a second. So let's look at this. This right here, 0, 1, and 1, 0 sum to 1. So someone could end up with 1 point. And we have 2 different ways. We have this way and we have this way. Those sum up to be 0.24. You could get 2 points. And you get 2 points 3 different ways. I can get it right here. Those sum up to 2. 0, 2, 1, 1. All of those sum to 2. So 0.09 plus 0.09 plus 0.16. If I add those up, they add up to 0.34. Then we have 3. And these sum up to 3, and that's also 0.24. Then we sum up to 4, which is 0.09. All right, so I'm going to check something out really quickly. If I did this right, and I'm not saying I did, we add all these up. So this is going to be 0.48, 0.34, 0.82. Yes, I did. These all sum up to one whole, and that makes sense. Okay, this right here is my actual answer. But if I make a valid probability distribution, they should sum up to one whole. And this plus this plus this plus this plus this does in fact equal 1. All right, we'll continue on in the next video.